session.
Good day, grade 12s. Today is Monday. Then we will be looking at the technical mathematics. The topic for today is we're going to be looking at mensuration. But before we can start our lesson for today, I just want to advise you that please get the examination guideline. It's a very important document. You can get it from the DBE website. It outlines the important technical mathematics. Now, let's start mensuration. Now, under content, I've tried to split out this mensuration into two. The first one will be looking at surface area and volume. And the second one will be Midordinate Rule. So under mensuration, these are two aspects that you will find. And then remember this topic, it formed part of paper 2. So it's very important topic where a learner can collect a lot of marks, right? Now let's get into the topic. Now, we'll start with the surface area and the volume. So we'll be calculating the surface area and the volume. Now, after we have completed this lesson, you must be able to calculate the surface area and the volume of the right prism, the cylinders, pyramids, cones, and spheres, and also the combination of this geometric object. Okay, and then second point, you should be able to investigate the effect of what? Of K, where we are calculating the volume and the surface area. If, let's say, for instance, we multiply our dimensions with the factor K. And the last point, determining the area of an irregular figure using the midpoint or the Midordinate Rule, right? Then remember, when we are referring to irregular figures, it's not the square, it's not a rectangle, it's not a triangle, but it's just a shape. And then we don't have a special formula for that. So then today we'll be learning on how we calculate the area of such irregular figures, right? Now let's get started. Now we are having the first example under surface area and the volume, and see what are we going to expect when we are writing our trial exam or the final examination. Now the first question, it says determine, the diameter of the sphere is 12 centimeter. Let me just show you. The diameter of the sphere is 12 centimeter. Now the first question says, calculate the volume of sphere, round off the answer to 2 decimal place, right? Now first we'll be calculating the volume of the sphere. Now let's see how do we calculate the volume of sphere. First, remember, for us to be able to calculate the sphere, we need to know the radius of that particular sphere, because from our scenario, we are having diameter. So meaning for you to get what? Radius is going to be 12 divided by 2, because remember, radius is half of what? Half of diameter. So now in this case, we can see our radius is 6 centimeter. Then we must write the correct formula for volume of sphere. And then remember, my dear learners, that these formulas of surface area and volume, we don't get it from the formula sheet. So make sure that you do study them so that by the time you go and write your trial exam or the final exam, you remember on how to calculate and even to write the correct formula for that particular object that will be having. Now, this is the formula for volume of sphere, which is equals to 4/3 pi r cubed. So in this case, you can see that pi is what we know is a constant number. So what we have to know is the r, which is radius, and we have determined that, which is 6 centimeter. So the second step, you just substitute 6 into r, and then you just press your calculator. Then the answer is 904.78 centimeter cube. So it's very important every time when you calculate the volume, at the end of everything, write your units. It's very important because if you don't include this unit, then you might not get a mark for that. So it's very important every time when you calculate, for instance, a volume, you must write centimeter cube, right? To show that you are calculating for what? For volume. Second question, calculate the surface area of this our answer to 2 decimal place. Okay. Now, first we have to write the correct formula for surface area of sphere, which is 4 pi r squared. Right. Then we are going to be substituting 6 where we see r, and then you just press your calculator. Now our answer is 452.39 centimeters squared, right? And then let me emphasize the point. Please write down the units. It's very important. In this case, we can see we're calculating the surface area. Hence, our final answer, it is in terms of what? Centimeter squared, to show that we are calculating the area. Okay, so that's how you should calculate the volume and the surface area of what? Of sphere, right? Now let's proceed. We're still under surface area and the volume, and then let's see what are we going to get. All right, we are having a question, but first it says the sphere has a volume of 86.5 centimeter cubed. Now in this scenario, we are given what? The volume, right? Now first question says we should calculate the radius. In this time, we have to calculate the area of the sphere. Round off your answer to 2 decimal place. Remember, from the previous slides, we were calculating what? The volume of sphere. Now in this case, we are being given what? A volume, and then we have to calculate what? Radius, right? But still we are going to use this very same formula that we used to calculate the volume of sphere. Then now in that case, then we will be calculating what? The value of radius, right? Now we have to make this r the subject of the formula. But the second step, we are going to substitute. You can see volume. Our volume in this case is 86.5 equals to what? 4/3 pi r cubed, right? Now the third step, because we are calculating radius, then we'll have to divide both sides by 4/3 pi, right? So you can see the third step is what we did. We divide both sides by 4/3 pi. Thereafter, you can take a calculator and get the answer here, and then you will get 20.65035. Please, learners, let us try to avoid of rounding a number before you reach to the final answer. We only round off when we are at the final stage, right? At the end of everything else. That's where we're going to start doing what? Applying this instruction that says we should round off to 2 decimal place. But before you reach to the final answer, write everything. Write every number that you see on your calculator. All right. Now, because now we are in need of R, and then look at in this stage, we have R cubed or R to the power 3. Now we need to get rid of this 3 here. Now let's see on how do we do that. Then we're going to put cube root both sides in order to remove this exponent 3. Or what we can do, you can multiply this exponent 3 by 1 over 3. And remember what you did, what you do on the right hand side, I mean on the left hand side, you must also do on the right hand side, right? You can see that I did put this cube root on the left. I also put it on the right hand side so that I can be left with R. And then you can see our answer for the radius is 2,4 centimeter. So we have just answered the question. It was very interesting question, but it will be easy for you to calculate if you know the formula for volume of what? Of sphere. Just if you just know the formula, then everything is going to be easy for you to calculate. Okay, and then let's proceed and see what we are having next. Okay, we still have same answer. All right, we have another example under surface area and the volume. All right, the first question says calculate the volume of cone. We are now talking about cone now. You can see on the screen we are having a cone with a diameter of what? 18 centimeter and the height of 24 centimeter, and round off the answer to the nearest whole number. Okay, and then let's see how do we calculate. First, you have to write the correct formula for what? Volume of cone. So it says volume equals to 1 over 3 times area of base times height. Area of base times height. Now we can all see on the screen that the area of base is pi r squared, and you also have h, which is our height. Now, in this case, we can see that we have r, which is radius, and then from our question, we are having what? We are having the diameter, which is 18 centimeter. Then we know that the radius is half of what? Half of diameter. So now when you just divide 18 with 2, then you get 9. Then hence you see 9. And then for h, which is our height, is 24 centimeter. And then after this stage, you just take your calculator and then it will give you 2036 centimeter cubed. So that is the volume of what? Of cone. All right. And then we still have another question. Number 2, calculate the surface area of a cylinder in centimeter, centimeter squared. If the height is 26 centimeter and the radius is 100 millimeter. Now you can see that we are having another unit there, which is millimeter, but we have to calculate the surface area in terms of centimeter cube. So meaning, centimeter squared. Then we have to convert this 100 millimeter, right? And then let's see on how do we convert that. Millimeter to centimeter, you all know that we are going to be divided with what? We are going to divide this 100 millimeter with 10, then you're going to have what? 10 centimeter. So it's very important, learners, that you go and revise also on how to convert the units, right? Millimeter to centimeter, or centimeter to meter, or meter to kilometer. So it's very important. So then let's proceed. Then you first write the correct formula for the surface area of a cylinder, which is surface area equals to 2 pi r squared plus 2 pi r h. Now question is, are we having radius? Yes. Our radius in this case, remember we had to convert it, is 10 centimeter. And then what about the height, which is h? Yes, we do have height, which is 26 centimeter. So we just substitute those values, then, and you press your calculator, then you'll get 2,262 centimeter squared. 2 centimeter squared. So in this example, we're calculating what? The volume of cone and then surface area of cylinder, right? Then it's also important that you know the formula for volume as well as the surface area for what? For cone. And the same applies with the cylinder. You must be able to know the surface area and the volume of that. Then you'll be able to calculate everything. And then let's proceed. Another example under surface area and the volume. The effect of, or the effect on volume and surface area when multiplying any dimension by the factor of k. Now let's get example. A sphere has a radius of 12. A sphere has the radius of 12, and the radius of sphere is multiplied by the factor 3. Then let's see on how it's going to happen, or what is going to happen if we multiply our radius by the factor of what? 3. The first question says we should calculate the volume of sphere with a radius of 12 centimeter and leave the answer in terms of what? In terms of pi. So it's very important. We should leave our answer in terms of what? In terms of pi. Now, we are now going to be calculating the volume of sphere. Remember, earlier on we had a question where we have to calculate the volume of sphere. Then we just going to do that. And then let's first deal with number 1 and see how do we calculate. And then this is the formula for sphere. And then we are going to be in need of r there. And then we have 12 centimeter as the radius. Then we're just going to substitute 12. And thereafter, you press your calculator. And then our answer now is 2,304 pi. Remember, we had an instruction that says we should leave our answer in terms of pi. Now, you only focusing on what? You don't press anything on your calculator. You don't press pi from your calculator. You leave pi as it is. You only thing what you have to do, just press 4/3 multiply by 12 cubed. Then you'll get 2,304 pi centimeter cubed. Okay. Then let's check the second question. If the radius of the sphere is multiplied by a factor of 3, calculate the volume of sphere and leave the answer in terms of what? In terms of pi. All right. Now our radius, previously we had 12 centimeter. Now we have to multiply by that factor of 3. Then it's going to give us how much? It's going to give us 36 centimeter. Now our new radius is no longer 12, but is what is 36 centimeter. Then let's calculate the surface area now. Then where you see R, we have to substitute with what? 36. Yes, it's 36. Then you press your calculator, then you get 62,208 pi. And then remember, you don't press pi from your calculator, because once you press pi, then it's going to give us a decimal number. So, but to avoid decimal number, you just proceed with this pi as it is, and then you just have to press calculator 4/3 and 36 cubed. Then you'll get this number, which is 62,208 pi centimeter cubed. Okay. The third question says, what do you notice about the effect on the volume when you multiply the radius by the factor 3? What do you notice about the effect on the volume when you multiply the radius by a factor of what? 3. Now let's see how does that factor of 3 affect our volume. There is a typing error on this one. Remember, the first question, we calculate the volume of sphere. The second question, we also calculate the volume of sphere. So now here it was supposed to be what? Supposed to be the volume. So we want to check how does the factor of 3 affect our volume. So it's supposed to be what? Volume in this one. So this is supposed to be volume, not surface area. It's just a typing error there. All right, now after taking the second volume divided with the second one, the first one, then you are getting what? 27, right? Now, what does it mean? When you multiply the radius by the factor of 3, the effect is that the volume is multiplied by the factor cubed. And then in this example, you can see that when you say 3 to the power 3, you get what? 27. Okay, so that is the effect of what? Of K. Okay, now let's proceed. The combination of geometric objects, but we are still under surface area and the volume. But now in this one, we are going to be having more than one object, and then we see how do we calculate that. Now the first says the object below. Let's see the object. The object is made up from cylinder and hemisphere. We have a cylinder. We also have what? Hemisphere, right? The cylinder has a radius of 10 centimeter and a height of 32 centimeter. Now, first calculate the volume of the object to the nearest whole number. Remember, we are having a cylinder and what? An hemisphere. Now, we're first going to be calculating the volume of what? The volume of cylinder. And then what is going to be our radius? We know our radius is 10 centimeter there. And the height is 32 centimeter. Then you're going to substitute the value and just press your calculator. And then that is the answer. So we have just calculated the volume of cylinder. Now we are looking for what? The volume of hemisphere. Now, if you remember, hemisphere is half of what? Is half of sphere. So if you know the volume for sphere, then it's not going to be very difficult for you to calculate hemisphere, the volume of hemisphere. Now, the volume of hemisphere, remember, inside the bracket, this is the volume of what? Of sphere. But because we know that the hemisphere is half of what? Half of sphere. Then hence we had to multiply by this half, 1/2. Okay. Then we just need R in this case, and then we know our radius is 10 centimeter. Just put your 10 centimeter here. Then you press your calculator. Then you're going to get this 2094.4 centimeter cubed. So that is the volume of hemisphere. All right. And then because we are calculating the volume of the whole object, then we have to now determine the total volume of the object. Then we're going to take the first volume that we calculate, and the second one, then you just make the sum of it. Then you're going to obtain what? 12,147.5 centimeter. So this is the total volume of that particular object. All right. You can see this is the picture. You can see now, number one, this is what? This is a cylinder, and then on top there we have what? We have number two, which is hemisphere. So that is the combination of these two objects. So, but we had to calculate the volume of both, right? The whole thing. So, but it will be very possible if you calculate the volume of the first object that you know, which is cylinder in this case, and then we also calculate the volume of what? Of hemisphere. Then after that, you just add the two volume so that you can get the total volume of the object. It was a very interesting question, this one. Now, I think we are done with the surface area and the volume. We are now into Midordinate Rule. We are now talking about Midordinate Rule. Determine the area of an irregular figure using the Midordinate Rule. Meaning, if we come across an irregular figure and then we had to calculate the area, then we're going to use what? The Midordinate Rule. Now, the formula that we are going to use of this Midordinate Rule says area equals to width of the interval multiplied by the sum of the midordinates. So this is the formula that we're going to use. Now let's get example, and then we apply the formula and see on how do we calculate that area. Example 1, it says calculate the area of the irregular shape. Let's see the irregular shape. Calculate the area of the irregular shape using the Midordinate Rule. You can see this shape here is irregular shape. It's not a square, it's not a rectangle, it's not a triangle. You know, if it was a square, we have a formula for area for that. If maybe it's a square, we have the formula for that. If it was a triangle, we have a formula of a triangle when we had to calculate what? Area, right? But you can see this picture here, this is a irregular shape, but we had to calculate what? The area of this particular object. Now let's see on how do we calculate that. Now first, we are going to be determining the midordinate, right? The midordinate, midpoint ordinate, right? Now first, what you have to do, you take the first ordinate. The first ordinate you can see in this case is 0 meter. The second ordinate is 2,5 meter, right? So you take the first plus the second, then you divide by 2. You can see, then we get what? 1,25 meter. So that is the first. Then you take the second ordinate plus the third ordinate. You divide them with 2, then you're going to get how much? 3 meter. Then you do the same with others. Then you're going to have 3,5 plus 5 divided by 2. Then you have what? 4,25 meter. Then you say 5 plus 4,6 over 2, then you get 4,8 meter, right? So now we remember we are determining what? The mid-ordinates. We want the mid-ordinates so that we can use the formula. Remember it says sum of mid-ordinates, right? So we're going to add them. But now we are determining what? Mid-ordinate. Then you say 4,6 plus 3,2 over 2 equals to 3,9 meter. The last one is 3,2 plus 0 over 2. And the last one is 1,6 meter. We are now having what? We are having mid-ordinate. And then now we will be able to calculate the area. First, width of the interval. Width of the interval. Now, width of the interval, we are referring to this distance from the first ordinate to the second ordinate. So what is the length between those ordinates? In this case, we can see is 10 meter, right? Is 10 meters. So that 10 meter is the width of the interval. So where we see width of the interval, then we're going to substitute what with 10 meter. The second step, you can see we have 10 there, multiply by the sum of the mid-ordinates. Remember, we have determined the ordinates, then we just add them together. We can see 1,25 meter, we're having it here. And then you just press calculator, put everything in on your calculator there. Then you're going to get 188 centimeter squared, right? Please don't forget to write the units as well, so that we can be able to see that we are calculating area. So in this case, actually there was a mistake as well on this one. The units is not centimeter squared, but it's meter squared, right? Let me just cancel this one. Our answer, the correct answer there is 188 meter squared, right? Not centimeter squared, because you can see the mid-ordinates as well as this with interval. It is in terms of meters, right? So our final answer should be meter squared, not centimeter squared. Example 2, we are still on mid-ordinate rule. Calculate the area. So A is left area, this is A here. Calculate the area of the irregular shape using the mid-ordinate rule. Now, first, we are going to be calculating the mid-ordinates. As we can see on the screen, the first ordinate on this picture is 140. The second one is 160. Then we're going to take 140 plus 160 over 2, then you get 150 meter. And then you do the same with others, which is 160 plus 200 divided by 2, then you get 180 meter. Then you move to 200 plus 190 over 2, then you get 195 meter. And then until you reach the last one, which is 130 plus 0 there, you can see at the end there on the right hand side, we don't have what? Ordinate. So in that case, the ordinate is 0, right? So it's 130 plus 0 over 2, you get 65 meter. Then you then write the formula, and then the width of the interval, in this case, you can see it's 50 meter there. Then you just put your values correctly, and then you press your calculator. Then you obtain 46,500 meters squared. So that is the answer for mid-ordinate rule for this question. Now let's proceed and see what we'll get. Then we still have another example under mid-ordinate rule. The irregular figure below has a straight side, 24 centimeter long, width divides into 4 equal parts. The ordinates dividing the parts are 12 centimeter, 9.3 centimeter, 8.5 centimeter, and P. You can see the last ordinate there is P, right? Now the length of P is half the length of the first ordinate. Write down the value of P. Now listen to this. The length of P is half the length of the first ordinate. Now, what is first ordinate? You can see our first ordinate in this case is 12 centimeter, right? Meaning P is half of that. Then let's see on how do we determine the value of P. Then it's quite simple. Half of 12 is 6 centimeter. Then now for P, we are having 6 centimeter. Second question, hence determine the area of the irregular figure by using the Midordinate rule. Now, since we are having value of P, then it's going to be possible for us to calculate the area of this particular irregular figure. First, we start with midordinates. Then you take the first ordinate there. The second one you divide with 2. Then you get 11.11 centimeter, 9.75 centimeter, 8.9 centimeter, and the last one is 7.25 centimeter. So after you have done determining the midordinates, you write your formula there. Now the width of the interval. Now look at what we are having on this irregular figure there. We are now not having what the distance between the given ordinates, but what we were having a straight line which is 24 centimeter. But now how do we get the distance between each interval, I mean each ordinate? Now because it is divided with 4 equal parts, then we are going to say this 24 centimeter divide with 4 equal parts. Then you're going to get what? You're going to get 6. Hence, under width of the interval, we are having what? We're having 6 there, right? Because we want to know from the first ordinate to the second ordinate, what is the distance between? Now, in order to get that, you're going to say 24 divided by 4, then you'll obtain what? 6 centimeter. Then after that, you multiply with what? With the sum of the ordinates. Then our final answer is 222 centimeter squared. So that's how you should calculate our midordinate, or calculate the area. Example 4, under midordinate rule. The irregular shape below has one straight side divided into 4 equal parts, 4 meters apart, and then the ordinates divided are 6.2 meters. You can see the first one is this one. The second one is Y. In this case, we don't have a number in terms of the ordinates. The second one, we have 5.1, and the other one is 4.9, and the last one is 2 meters. Let's proceed. The first question says, calculate the value of Y. You can see this ordinate there. We are having Y. Using the midordinate rule, if the area of the irregular shape is 72 meters squared. Now, in this case, we are now having what? The area. We are no longer going to calculate area in this time, but we are having area already. But we have only one ordinate which is unknown that we have to calculate, right? Then let's see on how do we go about it. Now, we first have to determine the mid-ordinate, right? We have to determine the mid-ordinate. Then you can see in this one is 6,2 plus y over 2, right? Is equals to, now remember y is unknown, is what we are looking for. So now after dividing this with 2, then you will have 3,1 plus y over 2. The second one is y plus 5,1 over 2, which is y over 2 plus 2,55. Then we have 5 meter there, 3,4 meter there. And now after we have determined the mid-ordinates, then you write your formula, and then the area. Remember, we are now having what? The area, which is 72 meters squared. And then what about width of the interval? You can see in this case is 4 meters. And then we also have what? Sum of the mid-ordinates. Now let's substitute and see. And then you can see that the first one was 3,1 plus y over 2, and then plus y over 2 plus 2,55 plus 5 plus 3,45, right? Now the second step, you can see if you add y over 2 plus y over 2, you get y. Then we're having y in this case. Then you're going to take a calculator and add 3,1 plus 2,55 plus 5 plus the last one, which is 3,45. Then you are going to get what? 14,1, right? Now, because we are calculating y, then we have to get rid of this 4. Then you are going to divide both sides with 4. Then if you divide 72 with 4, then you're going to get what? 18, right? Then on the right hand side, you can see that we are left with what? Y plus 14,1 equals to 18. Now, because we are calculating for y, then we're going to transpose this 14,1 to the right hand side. And then the value of y is 3,9 meter. So now we have determined the ordinate that we did not have, right? So this is how you should determine. This question is very interesting. As we have learned on how do we calculate the area, so it's going to be easy for you if you come across a question like this one where you have to calculate one ordinate which is unknown. Then just substitute everything, then you make whatever you are in need of, where the subject of the formula, then you calculate that value. Okay. All right. Thank you very much. This is the last for our lesson, and then we are having a message for you for today's lesson, which is never give up. Today is hard, tomorrow will be worse, but the day after tomorrow will be sunshine. I thank you.